I normally buy my parts off Rock Auto, but right now it appears that they're out of stock. And in the trunk of that Chevelle when I bought it, it had a lot of parts. And they both have the same motor and actually have the same carburetor. Now this kit has been opened up, but I believe there's enough of it in here that I think we can actually go through this one. I think the only thing missing in this kit is the air cleaner and your base gasket. I'm pretty sure that's all that's missing. I actually have a new accelerator pump. And have a new needle in the seat. New check balls. Some various, I'm missing most of the little clips and things like that, but probably the ones off this carburetor can be reused with no problem. Okay, but let's see what we can do. But one thing I did notice about this carburetor, I'm a little concerned that I have quite a bit of slack, which could actually cause a problem, getting me a vacuum leak. Since this one looks like it's been gone through at some point, it's really not that bad. Might be able to clean it up with a little bar saw and compressed air and just blow it off and go from there. See what we got. Well, here's the part that we've been waiting for. Got some additional, like a vacuum port back here in the back. It's got a boss threaded here, which is for the linkage for the choke for a BC. It's kind of a universal piece. It would probably fit B, BC, and the BV. And the original is cast iron. This one's aluminum. Overall, it doesn't look that bad. But the throttle shaft play was absolutely horrendous. Oh, it was worse than the original. I would have had a vacuum leak without a doubt. So I didn't know what to do. So I kind of started playing with the parts that I had here to see what I could come up with. But you'll see that that hole is oblong, that throttle shaft. This is the outside. This is where the linkage is. This is the opposite side, and it's oblong. But if you can see that, there's rough casting right there. So evidently this hole is actually just cast into the this base, and then the final machining is done to fit that shaft. So I kind of shut everything down and started disassembling to see what I could fix with what I had. And I think I actually might have worked out something really, really good. Now this is the original, and we had a lot of slack. And this is the side linkage and the throttle shaft from this unit here. Now this throttle plate is the original because it fits this bore. And if you also notice, you'll see those machined holes. See how they're cut into the throttle plate? Those holes right there are on the other side, make up the manifold vacuum that runs your vacuum advance on your distributor. This is your idle mixture screw, and it actually comes through also. And if you notice, it's lined up, and it's so close to when the throttle is closed. When they do the final machining, they evidently do it individually on each unit. I mean, that way they fit. So you can't necessarily take a throttle plate out of one and put it in another, and necessarily it's going to work. But where I was amazed was that the throttle shaft was such a copy that it fit. And there's a slight amount of slop, but that's just because this base has got 1,000,000 miles on it. But it's a lot less than it was. And this step was machined so close that when I put it in there, I was able to move this throttle plate around enough to where I was able to line up all the holes perfectly. And it closes and snaps just like it's supposed to. And where the other one was staked on here, see how over the years people have been knocking and peening it over trying to get it to stiffen up. It's just floppy. And I could have brazed it, or I could have cut this off and then drilled and tapped the end and then put a screw in here like this other one. But the shaft itself, you notice, I mean, it's just got so much wear on it, it just really wasn't worth trying to repair. So I think we ended up with actually something better than what came. This is for a B, this base. This linkage is the correct linkage for the throttle on this particular model. So that worked out. And it's already tapped and threaded. The cross shaft was an absolute perfect fit. The throttle plate fits in there better than I could have hoped for. And so I think we ended up with a really good option here. So I spent $29 for that throttle shaft, but you know, I would have probably spent more than that trying to repair this one. So I guess in the long run it worked out. So that's got that part taken care of. So then before I started going any further, I wanted to see if I was missing anything else was broken. Then I came across power piston, and look at the tip of that, how it's all damaged and mushroomed over. This came out of a remanufactured carburetor. So I don't know if, I know they make different power pistons. There was slightly different variations through this production of the Rochester Bs. So maybe some of them were longer, some were shorter. Maybe this one was installed in something else that was too short. And when they went to go tighten everything up, it just crumpled the end of this thing. I mean, God only knows. I don't know. What you say we try to put this thing back together? I'm not sure if they just were smart enough or lucky enough to get the proper carburetor, but it turns out this tag on here, 702-7011, is actually the number called for this particular truck. So I guess it's possible that this is actually the original carburetor that somebody went through, or they got lucky enough when they did a swap, when they got a remanufactured carburetor and did an exchange, that they just got the proper one. But I'm probably betting that this is probably the original one and somebody went through it. And I'm not sure what part of the other video that I did yesterday showed up, but the tip of this power piston was actually damaged. It was all mushroomed over. You can't buy these separately, and I don't have access to another carburetor right now. But I used a machine piece of steel. It was a good flat heavy base and a small ball peen hammer, and I just massaged it and worked it over until I got the thing pretty much straight and round. And I don't believe I lost any overall length. So I think we salvaged the power piston. And my gasket set, unfortunately, had been robbed of so many parts. It turned out that this is a later B, and this kit was for an earlier B. The accelerator pump is the flat type upper shaft. The needle and seat, I haven't even opened up the package because it appeared that they were slightly different. And I'm sure it probably would have worked, but because the other one looks like that this has actually had a kit installed from a mileage standpoint not very long ago. So I opted just to not do it, since most of the kit I'm going to have to actually reuse most of the older components, unless I want to spend about $40 and get another kit so I can get a couple of gaskets. Here's the original gasket that was in it. I'm probably going to go ahead and reuse it because it's got all the proper holes in it. The gasket that was left in the kit has this hole in the wrong spot, and I was just going to flip it over and trim the gasket, but unfortunately there's a vacuum port here that has to be serviced, and there's not enough material here to open up and make an opening for that vacuum port. So this gasket is obviously for something else. But because this gasket does not have any tears in it whatsoever, and it's still in good shape, I don't recommend it, but this situation we're going to give it a shot, and I still think we're going to end up with a really good carburetor. So we've got the throttle base, or I guess the throttle bore, repaired. I think I've got enough gaskets. This is a new gasket, and it's the proper one. The floats don't leak, so this is in good shape. I had a tweak on them, and I'll show you when we measure the float drop and the float level, but this thing had been twisted around so much I didn't want to waste time on camera, so I went ahead and got it adjusted, but I'll show you where to measure from. And this is also part of the power piston system. And this one, and I didn't really notice it at the time when I took it apart, but I thought about it later on. There's a check ball in here, and there's also a spring that holds that check ball down, and then you have a cap that holds it in. Well, when I disassembled the carburetor, there was no spring in here, which meant that this power piston portion of the carburetor was basically null and void. It wouldn't have worked. It would have just run rich. This ball would have been off seat, because this is upside down in the carburetor. So the ball would have not have been on seat. It would have been falling down, which would have allowed fuel from the bowl to make its way in there. And if you can see, this is where the fuel, once it goes into the power piston during heavy demand or wide open throttle, if you can see that orifice in there, which is, in essence, it's just another jet. And that supplements the fuel from the main jet under heavy demand. And during idle or cruising down the road when you have high vacuum, this piston is sucked back, and that ball is pushed back on seat with that spring, preventing fuel from making its way in there, which leans it out for times when you don't need the fuel for fuel economy. Well, I was missing a spring, and I don't even have one to even look at. So I looked at multiple videos trying to see if I could come up with something. And this kit actually came with a spare spring for the accelerator pump discharge. So what I did was I kept the new spring to replace the spring in the discharge, and I cut down the other old spring. It fits down in this bore. It makes contact with the ball. And because I had no idea what length it was, I had to just look at videos and just kind of take a best guess, the ones I saw based on proportion, you know, their finger size and how it sat in the hole. And I actually think that this thing is going to work perfectly. Put the ball in there. Put this spring. Put your cup, cap. That ball is off seat. And can barely touch it and take the ball off seat. And it goes back a long way. So, I mean, it's not being, the spring is not compressing and stacking up and then preventing the ball from opening up. It's actually going back pretty deep. And then it snaps shut. So, I believe that we might actually have a power piston system now. So, as this thing comes up on low vacuum or wide open throttle, it actually off-seats that ball. And when it off-seats that ball, fuel pours around that hole, fills up this cavity, and is drawn in through that orifice, metering the fuel into the main circuit, this is where the main jet goes, and feeding through the rest of the carburetor through that little screen. I've already removed it and cleaned it up and shoved it back in there. It's just like a little cone. You can see the tip of it right in there. All right, how about we try to put this thing back together? Again, I wouldn't really recommend putting one together with all this used stuff, but thankfully the carb had evidently been gone through from a mileage standpoint fairly recently. All the gaskets were in excellent shape. I just went ahead and reused I got a new one for the between the throttle bore and the float bowl, because I had one and it worked, so I'm just going to use a new one. Between the float bowl and the air horn, I'm going to have to reuse that old gasket, because this is evidently a different model. There's different man, they made so many variations of this B. This must be a later B, because I think 67 was the last year that they actually used it, and then they switched carburetors, I think, in 68, and they went to a different type of Rochester. There's a hole right here. This is going to make up the other half of that accelerator pump circuit. It doesn't go anywhere. I've already checked that. It's a blind hole. But the fact is, there's a lot of volume there. And some of these other tops that I've seen, this boss right here is not drilled out. I mean, it's just solid. And that's your discharge for your accelerator pump. You notice those two halves they made up. Well, I didn't want that hole exposed, even though it doesn't go anywhere, because it just takes up volume. So for every travel of that accelerator pump, it can only move so much volume of fuel. So what it's going to have to do is fill up this hole before it starts to shoot it out. And the discharge hole on this thing for the accelerator pump is this. Again, I apologize. My next acquisition is new glasses, because I can't hardly see. But this little hole right here there's a check ball and a spring and a little keeper that holds the spring and everything in there. And then the top actually holds everything together. But as that accelerator pump pushes down, it lifts that ball off seat. And then once it's pressurized, it actually discharges it out this little hole. And it should be a good steady stream. But I have this big volume of emptiness up here at the top, which means that most of the stroke of that accelerator pump is going to have to fill up that cavity before it actually shoots it out, which wastes most of your accelerator pump. So the old gasket actually was solid. When it sets on here, which way is this thing going here? Right here. It'll block that hole off, which is fine. But the gasket, I could have flipped the new gasket that I got, probably for a different B. I really wish I could have used it because it's a nice quality gasket. This is actually a Delco reaming. This is a factory original replacement. But if you notice down there, there's a hole there, which would allow it to have access to that cavity right there. I couldn't flip this over where it was blocked off, because then I wouldn't have had a gasket to cover this vacuum port, which has to have a gasket around it because this is what services, I mean, that's part of the vacuum circuit, so I couldn't block it off. And there's not enough material here for me to cut a hole out. So I really couldn't use this. And I thought about filling that hole with JB Weld and all that kind of stuff. And I said, you know what, let's just use the original gasket that was on there, and it'll block that hole off. So that was the reason why I chose to use this original gasket. If not, the only way for me to get one would be to order a whole new kit. And then the other portion of the kit, which I think I already mentioned, was this accelerator pump. It's got the flat type, and this is a later model, which has the round one. And then there's a little clip that that retains it at the top. This just kind of latches in. But because this is so new, this cup is actually, it's really soft, it's pliable. I don't see any damage whatsoever. So this carburetor has not been assembled with this kit in it for very long. It has not been exposed to much fuel for any length of time. So this is still in good shape. And the Viton tip on the end of here is in good shape. Still soft and pliable. I don't see any damage or any impressions or dents or dings or anything like that. So I think we can still reuse a needle in the seat and come out with a good carburetor. We made a repair for the power piston, and I think I got enough springs now put together that I think we can make it work. And then with repairing the throttle bore, the throttle body, I guess, and everything lining up perfectly, a little bit of Loctite, and that was pretty much it. And it works good. So we're going to reassemble this thing, and we're going to have a carburetor that's actually going to work really well. And I chinched on it, but I just didn't want to spend another $30 or $40 by the time I got something delivered just for a few gaskets and stuff, when I know that what I had is actually going to work just fine. Only because this carburetor had not been gone through too long ago. But it would have not worked with the amount of corrosion inside. The powder would have just caused issues. Power piston was a little bit frozen, a little bit stuck. And not only that, the end was all mushroomed over. There was no spring in the main well support, so that wouldn't have even worked. And it would have run rich all the time. So you would have been fighting why this thing was always running rich, and there was nothing you could do to make any adjustments. It was just dumping fuel where it should not have been. And when you clean this thing, if you have access to compressed air, it's highly advisable that every orifice and every passage on these carburetors gets blown out good. Because sometimes it doesn't take much to cause a problem, but boy, you're going to spend a lifetime trying to figure out what's wrong with it. And and all right. And I'm going to reassemble my accelerator pump. Got this long spring. And find the little clip. These are kind of like a, this is the new one that came with a kit, but these are kind of like a one-use type clip. You put it around there and then you bend it, and then pretty much not worth it once you use them once. So crimp this thing around here. I dumped a little bit of fuel in this accelerator pump reservoir, and I was going to show y'all where this thing actually discharges at. Hope you can see on the tip of that screwdriver about where that hole's at. And it's a good idea to check to make sure that everything is working properly before you get this thing all put back together. But I just put a little fuel inside the little bore, and we should have a good steady stream come out of that tiny little orifice. Yep. She be's working. All right. Well, I've emptied out the gasoline, blew it out, and smeared a little bit of oil on that cup seal. Also, another thing I noticed, so if anybody was actually interested in purchasing one of these carburetor throttle bodies from that for the replacement for this B, that hole right here for the linkage for the accelerator pump, you'll notice that hole is far too big. And if you'll notice, this little rod diameter is not very big, and they've already got shoulders cut in them just from wear, so there was a lot of slop. So what I ended up doing, shout out to a friend, Don, he, for being out in the middle of nowhere, his shop seems to have everything. It's like going into a mega hardware store. These are inserts into like a plastic line, like for say like air shocks, things like that. Slip it inside the little clear plastic line, and then compression fitting has something to bite a hold of. These are just like little insert little bushings. I took one of them because it was the perfect inside outside diameter. I could just cut it off, and it fits inside here, and it takes up a lot of the slack. Actually just about all of it. I'm going to get this linkage put on here first. Well, hell with it. Yep, I believe that the crooked end moves up this way. Yep, it took up a lot of slack. I've been piecing this thing together, so I've kind of taken it apart and put it together a few times, trying to see what parts were needed to be tweaked on. And then I noticed that hole was too big, and it had a lot of slop in the accelerator pump. Well, you don't have a lot of travel to begin with, and these things are kind of anemic off the line anyway, so it kind of makes it worthwhile trying to make sure that you got as much accelerator pump as this thing can put out. So that took up virtually all the slack by comparison to what it was, for sure. All right, I'm gonna put this back in there, and then we'll get this hooked up. Make sure I don't have any trash stuck on the cup. think that's a winner. I think it's a winner. All right. I noticed in some of the videos, and maybe I'm just a lot more visual. Over the years, you watch something, and some videos are pretty decent, and they actually do a pretty good job as far as explaining things. But sometimes the camera angles and stuff just kind of cut things off, and you can't really see. Because sometimes people are putting these carburetors back together. They got them in a box. You know, you get somebody else's old project, and you get a box that's parts. And it's a good idea to be able to get a good close-up of everything to see what it is that you have and what it should look like or what you may be missing. Just like me. Missing that spring for the power piston. Thankfully, I just haven't realized that check ball is not doing any good if it doesn't have a spring on it. So I kind of did a little bit more looking into it. And I think what we have is going to work. All right. Install this power piston. It's got a long spring at the bottom that actually is what pushes this thing up when it loses vacuum. And I believe it's anything less than 5 inches of vacuum is when this thing starts to make its move. And I don't see anything in the bottom down there. Boy, I tell you one thing, I need a set of glasses. Bad, bad, bad. And that is nice and free. Nice and free. Then you have your main well support. Well, actually, we got to put this gasket on before I put that on. Hold this power piston down. One screw to hold it in. I always drop those screws in there and I back them up first, like I'm trying to unloosen it until I hear that click so the thread's engaged. Because it doesn't take much to get one of these cross-threaded, and then get one cross-threaded, and then you'll understand why you didn't want to cross-thread it. As good as any. We have our main jet. And these definitely don't have to be very tight. They definitely don't have to be very tight. They're not going anywhere. They are not going anywhere. And we have our little check ball. And we have our nice little homemade spring. And I'm sure y'all can probably still see that orifice. That's what supplements the main jet circuit. When this power piston comes up and off-seats this ball. We have our cap. And this again, this doesn't need to be very tight. And that works perfect. Yep, that works perfect. That thing is slick as a button. All right. Install our needle and seat and lint from that rag. And the one screwdriver that has walked off is my really big flat blade. This one will barely reach across. And you want to actually make sure that you have a screwdriver that'll go from side to side, because you don't want to be tweaking and torquing this this seat. But this one does make it, but barely. And again, these don't have to be very tight. There's a gasket in there. And I cannot see. I am running blind here. I'm going to blow this thing out with compressed air just to make sure. And the floats had been tweaked on so bad. You're actually supposed to use this tab to make your adjustment for your float level. And then this tab right here will be for your float drop. But what they had done is, man, these arms had been they were actually twisting the arms, and they were both too wide. They were dragging inside the bowl, and they were not even at the same level. So because it took so long to kind of get it all bent back into shape and where it doesn't drag, I didn't bother doing that on camera. I just got it close. But I'll show you the proper way, how Chevrolet recommends in their little book on how to get your measurements. And it even came with one of their vintage little handy dandy little freaking little measuring tools. Now, see if we can do this in a better way. Now you're actually supposed to measure it using the gasket in place. And according to the book, this is actually a piece of paperwork that came, and this sucker's probably older than the truck, or as old as the truck. And it asks us where I got the correct part number for this tag. So it showed that this was the correct carburetor for the truck. Chevrolet truck, 66 through 67. We're working on a 67. We've got a B model. And our float level is 1 and 9/32. And your float drop is 1 and 3/4. And your idle vent, of course, I've seen two separate areas on this thing which tell you something different. But on this particular piece of information, it gives it at 55 thousandths. So, and I still haven't quite figured out what that idle vent is, honestly, because the bowl itself is vented already. The bowl itself, you have this idle vent valve, but these two vents, that vent right there actually comes in and vents just next to this. So because this is outside the air cleaner and these are inside, I'm sure there's some kind of a pressure differential. So obviously this has something to do with fuel mixture at idle, based on difference in pressures between what's inside the air cleaner and what's outside. That's the only thing, because the early models didn't even have this. So we're going to be one tiny line above the number 8. And that's basically where we're at. and both sides should be the same. And then you have your float drop. Again, you measure from the gasket to the bottom of the float, and that should be 1 3/4, which on this little gauge is going to be 1 24. And that's 24. And that's 24. So we're good. You kind of feel it where that old gasket was kind of set down in those grooves. All right, on mixture screw. Kit came with a new one, but of course it was a different length. But this one right here looks fine. There's no damage on this taper. Sometimes they'll get a ring around it from somebody actually tightening it up too tight at one point, but this one looks fine. So we're going to start this thing. All right, I bottomed out. We're going to come back 1.5 turns. It's a good place to start. And then when you get it on the car and we get this thing running, we'll set it, make all the adjustments and work on the timing. About 1/2, 1, roughly about 1.5. All right. Then, and I think I just probably made this harder on myself. I should have put this on. Well, I've been tinkering with it. You can definitely get it on there like this, but learn from my mistake. Best thing to do is to install this thing when you just have the float bowl by itself. Get the spring on there. The spring will sit up with the bottom hook closest to the carburetor on this boss. And then just, this is going to be where your cam at the top rides, this section right here. This tab on the bottom is where your idle screw is going to push against. So then you're going to end up putting that on there. You're going to hook this. You can see that. You'll just end up hooking that. You'll drag it over, and then you can set your screw. And then when this is by itself, before you install either the bottom or the top, you just spin it around and it'll load that spring. I'm going to have to do it backwards, so it kind of takes a minute. But it can be done. Just don't do it this way. Install it when you just have the bowl itself. I think I'm just going to put a dab of Loctite on this screw. Because when I put it on there now and I try to spin it around, before I actually have the base down all the way where the spring can't move, it wants to jump up and roll up underneath, which prevents it. So I'm going to have to kind of push it back. So. And then you'll see that that spring wants to jump up. All right. All right. And now your choke is off. This is where your choke cable is going to attach to. As you pull on that, there's a cam. It's going to be riding on this lever right here. You pull that cable, your choke goes closed. And see, that cam is pushing back on this. And it's spring tension, so once it hits to a certain point, it can go further without damaging anything, but it's spring loaded. But it cams over. And actually, and then when it cams over, see that thing is moving back down here at the bottom. See how it's working the throttle? So that's, in essence, that's your fast idle. That's fast idle. And then as you start pushing back in on that choke cable, coming back, then it's going to fall back down to its normal position. This can't move anymore, so now this is just a stop. And then that's how you're going to adjust your base idle. This is for your distributor, and I'm not going to put any sealant on it. This is a brass fitting going into a piece of cast iron that's been in there for generations, and it's an interference fit. That brass is softer than that cast iron, so it gives. And not only that, if you're worried about it leaking around there, what about your throttle shaft? It's leaking right there. So anyway, I'll snug that up here in just a second. This is actually your fuel filter. And it seems like a lot of people end up putting them in backwards. But actually this opening here is what goes toward the fuel line. It's got more surface area to catch debris. That faces the fuel line coming in. This spring actually holds tension. This is going to go that direction. There should be a gasket in here that I don't have, but I'm not going to use this one anyway. I've got another one on order, and I'll leave a link to that one too. But there'll be a gasket in there to seal off. Then this spring tension will actually just push the filter up against that gasket, kind of seal it off. And then you have your additional gasket here for this nut to seal. And these are okay. If you have another inline filter, these are definitely okay. But I choose not to really put another inline filter in there in the engine compartment. Just another something else to cut into the fuel line that you got. And on the side of the road, if this thing ever gets plugged up, these little tiny little filters, they make them in a little paper filter that has a gasket on both ends. And I mean, they take up this much room. You throw them in your glove box, you can swap them out. And if you get in a bind on the side of the road, worst case scenario, and you're stuck, you just take the filter out, and so you can get you somewhere. But if you have another inline filter and it plugs up, unless you're sitting there next to a freaking a auto parts store or something, or you have one in your vehicle, yes, they're better. I'm not going to lie, but just for the sake of convenience, these aren't that difficult to replace. Throw them in your glove box, along with your points condenser on these old cars, and you got just about enough stuff to get you home, no matter what happens. So this right here is going to wait until the new filter comes, and I'll leave a link and show you the filters that I'm talking about. They're just a little paper element, roughly about that size, and they have a gasket on both ends, and it's just a miniature filter, and they filter down to a smaller micron, where these are actually pretty coarse. And not only that, they just don't seal very well. You know, you got the gasket. Most people don't put the gasket back in there, or they flip them around the wrong direction. But like I said, these are not bad, and they're reusable. You just clean them up and put them back in, but they just don't do as well of a job as the little paper filters. And at one time, the paper filters were virtually free. Now they're actually getting hard to find, and now they're $2 to, some of them I've seen as high as $6 or $8. But if you dig around, you can find them for like $2. But shipping is what gets you, so you have to order a dozen of them to make it worthwhile. But anyway, that's just old school. It's just how my dad did it. So that's how I'll do it. Idle mixture screw. Again, I am not 100% sure the purpose of this circuit. It has to do something with equalizing pressure inside this bowl, because this vent right here, the opening is inside next to this, but you have an air cleaner on here, so you're going to have a different pressure differential, where this is outside at atmospheric pressure. So somehow or another, this is equalizing pressure inside that bowl for whatever reason. And it's going to have something to do with some kind of a fuel mixture type issue. So all I'm going to do is set it for what the factory instructions said. This came with the carburetor kit. This is General Motors printed. No telling when this thing was printed. Actually, this thing was printed in March 12th of 68. So it's pretty close to being accurate. And the idle vent should open, and you'll notice this thing rides, and I wish I'd have showed that. This thing is on a spring. See, it's on a spring. There's a little nut underneath and a spring, and then this thing, and this just basically spring loaded. But this thing sits on top of the accelerator assembly. See, there's our accelerator rod. Remember, the accelerator pump is in this area right here. And if you notice, see how that nut moves up and down? It's sitting on top of that accelerator pump. So at idle, with the choke off, engine warm, and your idle set to factory specs, where it's going to be, the gap between the top of this air horn and the bottom of this screw, according to this and this particular engine, Chevy truck 66 through 67, it should be 55 thousandths. Idle vent, 55 thousandths. And down here, idle vent should open to specified dimensions with recommended idle RPM set and screw on low step of cam, which basically means the choke is off. Engine warm, idle at factory settings, and then adjust this from the top of the air horn to the bottom of this screw to 55 thousandths on this particular application. I've seen a lot of them in the book. I think even the factory manual calls for like 60, 65. I don't think that this is extremely crucial, but most of these are like around 50 thousandths. Most of these other applications that this carburetor is on is around 50. They call for 55 on the truck, which I have no idea. This thing is on some Pontiacs. They're down around 40. So I think if you shop for 50 and you cannot find the specs on your particular model, I think 50 is going to be a pretty safe number. Other than that, I think that this is what we ended up with. Kind of a hodgepodge of various parts. But according to this tag, it is, I guess, theoretically possible. And I've seen other trucks with this, and they seem to have this same makeup here. This actually has BC written on it. I don't know if that has anything to do with the carb that it came off of, or if that just happens to be a part number for this particular piece. But I have seen this exact setup on another truck of this era, unless that carburetor was swapped out. So it's possible that this whole thing is actually a factory carburetor, minus the throttle shaft. And actually original to this truck. All I know is it works like it's supposed to now. And I have a power valve circuit that works. I should have an accelerator pump circuit that actually works. And you can, man, it works like a champ. It's nice and smooth. I don't have a bunch of slack in it anymore. And I won't forget to snug this up. And I'll set this. It actually might be pretty close at where it sits right now, but I'll know once I get it on the car and I get everything set up and I get the idle set, then I'll set that. This is the last piece. But that's it, guys. That's your Model B off of a 1967 C20 with a 256 cylinder and manual choke. Actually, it's a very, very simple carburetor. And these are actually really good carburetors. I hear a lot of people bashing online in the little forums and stuff, and they talk about the next generation Rochesters, and I'm sure there probably were improvements made, but there's nothing wrong with these carburetors. The problem with these carburetors now is they're 55 years old, and very few of them are probably put together correctly with the right stuff, or they just have points of wear everywhere. Throttle shafts are wore out, linkage shafts and holes are wore out, so your accelerator pump is missing about half its stroke, or you have the little orifices and holes and passages where all this fuel is supposed to go. Most of these people don't know where that stuff goes. They take it apart, soak it, and blow it off and put it back together. But that doesn't mean that everything is opened up. You have the air bleed holes here on the top, which is important for... This one actually has two. That right there provides a vent. You got fuel coming out of this side of the bowl through your main jet. It comes across, crisscrosses across the venturi, and goes down the other side and provides fuel. Where's this thing coming around at? Yeah, it comes down the other side, and under the bowl it wraps around. If you'll see up underneath the bowl, there's passages that curve around. Goes down, it curves around, and it serves the passages for this idle air mixture. And then next to it, you obviously, we talked about the power valve. Once you knock that ball off seat, fuel floods into that cavity, and then there's a tiny orifice in there that feeds additional fuel into the main circuit. So, but you have to make sure all those little passages are open. I mean, these are very tiny, and there's not much fuel going through. All you have to do is block off just one portion and just a part of it or all of it, and then you're going to fight it, and it's going to run extremely poorly. So when you have it apart, make sure everything's clean. Understand where everything is going, and when you're done with it, there's nothing wrong with these carburetors. They provide plenty of acceleration. They're pretty durable. They provide pretty good fuel economy. One like this on my Chevelle when I drove up from Texas to the Midwest. About a 1,500 mile drive, and I consistently got 22 or better. And I have a little 308 rear end, Saginaw 3-speed with no overdrive, and a 256 cylinder just like this one. Car weighs about 3,200 pounds, I think, 4-door. And I got 22 on the highway cruising at 65, 70. So nothing wrong with these little carburetors, and they're about as simple as they come. You ever had a flooding issue when you're out somewhere and this thing keeps loading up? You got 4 screws. You take the top of this thing off, and there's your float. There's your needle. You pull out that little pin, pull your float off, take your needle out, and blow through it. You know, about all there is to it. There's nothing complicated about these little carburetors. All right, I also have, and I'm going to clean all this stuff up, and I'll show you the next thing that we have just show up in the mail, and then we'll start messing with that. All right, we had another package show up, and actually I hadn't even seen it yet, so let's just cross our fingers it was actually what it was supposed to be, and it's actually in good shape. Golly. This might actually be a real new old stock one. They claimed it was new old stock, but I was just like, no, I've just probably just been, I mean, shit, it's 50-something years old. Got a little surface rust on it, but these weren't painted from the factory anyway. But it doesn't look like it's ever had a seal on it. Man, this might actually be one that's never been installed. This might actually be like the last brand new one. Well, it ain't brand new, but yeah. A couple of these actually have star washers on them. And they leave scratches and marks where the screws had been. I don't see any marks on any of this stuff. Holy smoke. This might actually really be one that's never been installed before. I hope that's the right one. Look close. Looks just like the other one. Yeah, I don't even see any freaking gum in here from where it had the that gum seal. Yeah, that's just part of the mold got squished out. That's, man, I cannot believe that. It was listed that way. I didn't care. I just wanted one that was clean. But they claimed that it was in a box and had never been installed. Golly. That is awesome. That's not too bad for, I think I paid like 70 bucks or 70. I'll have to go back and look. I think I paid $75 delivered. And that doesn't look like it's ever been installed. Well, anyway, hey, I'm actually very excited. It's dirty, but it does look like it's never actually been installed. There's no wear marks or scratches in here from where the heater core would have been vibrating around. It doesn't look like it's ever even had any screws pass through these holes. Well, shoot. This is the last, probably the last one ever made. I mean, the last one ever sold. Well, shoot, man, you get lucky every now and then.